So, here we have to find the number of integral terms in root 3 plus 8th root of 5 power 256. So, suppose we compare this with x plus a power n. The given question, if you compare with x plus a power n, we get x is equal to root 3. So, that x will write it as root 3 I will write it as 3 power half. Then the value of a is 5 power 1 by 8, 8th root of 5 can be written as 5 power 1 by 8, and the value of n is equal to 256. So, now I will write the general formula for the expansion. So, we have TR plus 1 is equal to NCR x power n minus r into a to the power r. So, I will do the substitution. So, the value of n is 256. So, this is 256C r, will keep it as it is. In the place of x, I will put 3 power half power n minus r. N is 256. So, n is 256 minus r into a is 5 power 1 by 8 whole to the power r. Now, what does this represent? This represents the general term in the expansion. So, since the power is 256, there will be 257 terms which have this form. Now, in that we have to find how many terms are integers, that is without roots. Okay, now it happens that if you put r equal to 0 in this, suppose you put r equal to 0. Now, the value of r starts from 0 up to 256, because when you do the expansion, the first term is NC0 and the last term is NCN, where n is 256. So, the value of r starts from 0. Now, if you put r equal to 0, 256C0 is 1, so it is already an integer. Now, if you put r equal to 0, what happens is this half gets cancelled with 256 and you will get 3 power 128, which is an integer. And if you put r equal to 0 here, anything power 0 is 1, so you will get a integer. So, for r equal to 0, this term will be an integer. Now, if you put r is equal to 1, it is not an integer, because if you put r is equal to 1, you will get 5 power 1 by 8, that is 8th root of 5, which is not an integer. So, now we have to pick which is the next value of r which makes this integer, and we can easily see that the next value of r is 8, because if you put 8 here, 8 by 8 becomes 1, so you will get 5, which is an integer. 256C8, NCR is always an integer, and if you put r is equal to 8 here, we will get 256 minus 8, that is 248. 248 by 2 is an integer, and like that you can check that this happens for the multiples of 8 because of this 8 here. So, and this is 2, that is okay. So, the moment this is a even number, it will get divisible by 2, but the problem comes here. So, for multiples of 8, this becomes a integer. So, the value of r will be 0, 8, 16, etc. and the last value which r can take is the power, that is 256. Now, we will just see whether for 256 this becomes integer. If not, we have to search which is the nearest one which is less than 256. Now, you know 256 by 8, 8 goes in 256. So, therefore, it will become an integer. 256 minus 256, 0. So, 3 power 0 is 1, which becomes an integer. So, therefore, 256 is included. In fact, 256 is a multiple of 8. That is why the last number here is 256. Now, corresponding to 0, 8, 16 up to 256, corresponding to these numbers, these terms will become integers. So, now my job is just to check how many values are there from 0 to 256. Now, this is an arithmetic progression. So, you can use this formula, Tn is equal to a plus n minus 1 into d. Tn is the last term, that is 256. A is the first term, that is 0, plus n minus 1 into common difference of this arithmetic progression is 8. So, you will get 256 is equal to n minus 1 into 8. So, if you cancel 8 3s are 24, 25 1 carry, we will get 8 2s are 16. So, you will get n minus 1 is equal to 32, and therefore you will get n is equal to 33. So therefore there are 33 terms which are integers in this expansion, and therefore option C is the answer.